not the drug, but rather the metabolite.
That's correct. It includes both the active form of the drug, lorazepam, but it also includes this thing here that the liver makes, which is the drug plus this sugar molecule over here. Both were included in that 648 number.
And why was it that you were seeking out this standard operations procedure from Pacific Toxicology?
I was seeking this out because you expect the metabolite to show up in the stomach. That's completely expected. And I thought that perhaps the number that was measured was almost entirely just the metabolite.
Which means the 634 nanograms per milliliter, if you're looking just at the drug, would be an inflated number.
Substantially inflated, yes.
Now, the results of the defense testing do show that lorazepam was found in the stomach, even if it was an inflated number, correct?
Correct.
And how did, assuming intravenous administration...
Dr. Shafer is making a gesture with his hand.
May I ask you a question?
Not me. You could probably ask Mr. Walgren. You want to clarify something?
Yes, yes.
You can inquire, Mr. Walgren.
Could you please clarify what you need to clarify?
What you said was that, thank you. What you said was that what I concluded was that lorazepam was found. We don't know what it is precisely because both things are there. It may have just been lorazepam. It may have been lorazepam glucuronide. We don't know from the information that we have because both were measured because of the treatment, because of the removal of the sugar molecule. Both were measured. I just wanted to clarify.
As far as making a precise breakdown, you mean?
Correct.
Okay. But you would, based on the science and the literature and what lorazepam does as far as a pharmacokinetic modeling, you know there's glucuronide included in that number of 634
Yes, absolutely.
nanograms per milliliter.
Yes.
But the Pacific Toxicology results don't differentiate, so as far as ascribing a particular number to both the drug and the glucuronide, we don't have that information.
Correct.
Now, you're aware from Pacific Toxicology's findings, however, that they did find lorazepam in the stomach.
They found both in the stomach.
Correct. Okay. And how would that arrive at the stomach?
So to understand how lorazepam gets in the stomach, I'd like to track a molecule of lorazepam through the body for just a moment.
Going to this slide, is this...
Again, to orient, this is the same slide that I showed before.
Your Honor, could we dim the lights, please? Just the third.
Seo?
Thank you. Please.
This is the esophagus coming into the stomach. We have here the liver, and we have the gallbladder up here, and the portal circulation all appears here. This is the stomach, the small intestine, and the large intestine.
Going to the next slide. What is shown here, Dr. Shafer?
What I want to do here now is take a look underneath the liver to explain how the gallbladder sits. This is looking underneath the liver. The stomach is here. This is the gallbladder. And the gallbladder is attached to the biliary system, the system the bile flows through right here. And it comes down here and it drains into the small intestine right after the small intestine sort of breaks away, doesn't break away, but let me say right at the beginning of the small intestine, just beyond the stomach, at the start of the small intestine, that's where the gallbladder and the bile drain into the intestine. So this is the gallbladder, this is the bile duct shown here. Here's the small intestine, here's the stomach, and this is the liver up here. I also want to point out that there's a blood supply to the liver, and it has two blood supplies. There's an artery right here, called the hepatic artery, and there's a vein, this blue piece right here. This blue piece here is the portal vein. This large blue right back here is the vena cava. That's what's going right back to the heart. But this is the vein going to the liver.
Now, assume lorazepam is given intravenously. How does an injection, for example, in the arm or but by IV, how does that get into the stomach from an IV administration of lorazepam?
So first it's injected into the venous system, as shown here. And then it comes into the liver, and this is the lorazepam molecule. It comes into the liver through either the artery that goes through the liver, or it's also in the veins. It's in all the veins in the body. So the vein that goes to the liver will also have lorazepam. So between the artery and the vein that lead into the liver, this molecule of lorazepam will then enter the liver. This is an intravenously administered molecule coming in by way of the artery and the vein.
And what is depicted in this next slide?
Here, you can see the lorazepam molecule in the liver. Comes in through the blood supply of the liver, and it goes into the liver.
And again, just to be clear, what we're talking about is the drug, the actual lorazepam molecule.
This is the active drug, the stuff in the glass vial, now going into the liver.
And once it goes into the liver, then what happens?
So this is a little hard to see, but this is lorazepam, and here is the lorazepam with this little sugar on it. So the liver converts lorazepam to lorazepam glucuronide. The liver is taking the lorazepam molecule and adding a sugar to it. That makes it possible for you to then get rid of the molecule in the urine.
And is there literature that documents the fact that the lorazepam or lorazepam glucuronide would then go into the bile ducts and gallbladder?
Yes, that's what this is. There is substantial literature on this subject.
Okay. And well, let me just take you, go through this next slide if you could.
So what happens is you now have this lorazepam glucuronide molecule in the liver. Where does it go from there? About 75% goes out of the liver by means of the vein, the hepatic vein that leaves the liver. But about a quarter of it goes into the bile. And here I have in this black line the lorazepam glucuronide going into the bile, and it either goes into the bile duct here or it can go into the gallbladder and just be stored there. But about a quarter of it does not go out in the vein, it goes into the bile, as shown here. And the bile then drains it right into the intestine at the junction between the stomach and the small intestine.
And then from there, can you describe how, if you take lorazepam via IV administration, how it would then end up in the stomach?
Slosh may not be a very medical sounding word, but it sloshes into the stomach. The bile's coming in there. Most of it goes down into the small intestine, but some sloshes back into the stomach. That's why vomit is green. Sorry to put it that way, but that's the reason. And so these are showing the lorazepam molecule being distributed throughout the stomach. But it's lorazepam glucuronide. It's the metabolite that has been created by the liver that then sloshes into the stomach as part of the bile.
And the rest?
And then the rest, you can see here I've tried to put the little molecules coming down here. The rest flows down the small intestine and into the colon. So 25%, a large amount of the lorazepam is converted to lorazepam is converted to lorazepam glucuronide. 25% of that goes into the bile, and from there it goes right into the intestinal tract. So that includes a fair amount of drug being delivered directly to the stomach, but the drug being lorazepam glucuronide.
And this depicts then kind of the path that it would take in this final slide?
Correct. 25%, about a quarter, of the drug winds up going into the intestinal tract. And that's how lorazepam gets into the stomach, in the form of lorazepam glucuronide. That's how lorazepam, in the form of lorazepam glucuronide, gets into the stomach.
Then, based on your understanding of pharmacokinetics and in this field, is it expected to get a positive reading for lorazepam in the stomach?
100%.
Okay. That's an expected result.
Absolutely.
And again, an expected result with the administration being via IV administration.
Correct.
Now, based on, back to the findings of Pacific Toxicology, that they concluded, without differentiating, but concluded that there was 634 nanograms per milliliter. That result, let's just take that result standing on its own, 634 nanograms per milliliter. Did you calculate that out to be 0.047 milligrams?
Correct. There's only, if you take the concentration and multiply it by how much fluid there was, it winds up being this rather trivial amount of lorazepam.
And the visual depiction at the top of the slide, does this represent to the right literally 1/43rd of a single 2 milligram tablet that was found in the stomach?
Yes, it does. I actually did the mathematics so that was in fact 1/43rd in terms of the area. It involves taking the square root of 1/43rd, but yes.
Okay. So you're saying, so actually visually...
Visually, that's correct.
This literally is 1/43rd of a tablet?
Correct.
And that's what was found in the stomach?
Correct.
Okay. Now, this slide summarizes your conclusions that the finding of lorazepam glucuronide in the stomach is expected?
Absolutely.
And what other conclusions do you draw?
Well, the other conclusion is that so much lorazepam glucuronide, 25%, goes into the intestine that most of this is the metabolite. It's not lorazepam itself. This is mostly metabolite. The true amount of lorazepam is much, much smaller.
When you say the true amount of lorazepam, you're saying the actual drug lorazepam?
Active drug. The active drug is much smaller than this. And given that that this number represents an extremely small number, mostly metabolite, the results of Pacific Toxicology prove that Michael Jackson did not ingest lorazepam.
Objection. That's mischaracterized actually what's on the board. I believe you need to finish that.
I'm going to sustain the objection, strike out the last answer, disregard it. Ladies and gentlemen, you may ask the question, Mr. Walgren.
Based on the findings of Pacific Toxicology and the findings that amount to 1/43rd of a tablet in the stomach, do you, based on your expertise, find any supporting information to support the theory that Michael Jackson orally ingested tablets of lorazepam?
There is not a...
What time?
I'll get to that. Thank you.
Well, I think you got to put that in the hypothetical, so in the opinion. So the partial answer is stricken. Disregard. We asked.
What time period are you talking about?
In the time period for several hours prior to his death.
Okay. So for what's several hours?
6 hours.